Okay, so now we're going to explore stoichiometry in more detail. We're going to look at a couple of examples where we have to employ what we just discussed in terms of calculating, for example, the mass or moles of a substance if you're given the equation. Just different possible scenarios. All right, so the first type of problem we're going to look at are problems where you're going from the moles of one substance to the mass of another substance. All right. So the object of this type of problem is to calculate the mass of one substance that reacts with or is produced from a given number of moles of another substance in a chemical reaction. If the mass of the starting substance is given, then the first thing we need to do is to convert it to moles. And then we use the mole ratio to convert the moles of the starting substance to the moles of the desired substance. And then we can change the moles of the desired substance to the mass of the desired substance if it is called for by the problem. So let's look at this first example here. Now in this example, fortunately they gave us a balanced equation. As I said before, they don't need to. In some cases they might give you the equation which is unbalanced. In other cases they might give you the reaction in words and you have to figure out what the balanced equation is. But in this case, they gave us the balanced equation and they gave us the mass of one reactant, which is this phosphoric acid. So they gave us 784 grams of the phosphoric acid, and you are to convert that to moles of sulfuric acid, H2SO4. All right. So the first step would be you take the grams of phosphoric acid, H3PO4, and you have to convert that to moles. So the conversion factor you're going to use here is where you have 1 mole of H3PO4, and then down here you're going to get the molar mass of phosphoric acid. So let me try to get that here. So phosphoric acid, so when I calculate that, I got 98.00 grams. Let me write that here. 98.00 grams of phosphoric acid. So this unit will go with that unit. So up to this point we would have determined the moles of phosphoric acid. And then the next step is where we look at the mole ratio between the sulfuric acid and the phosphoric acid. And if you look at this equation here, you see that there's a coefficient of 3 for the phosphoric acid. There's a coefficient of 5 for the sulfuric acid. So in this conversion factor, in the numerator part of it, I'm going to put 5 moles of H2SO4, and down here, 3 moles of H3PO4. So when this unit cancels with that unit, the only unit you're left with would be moles of H2SO4, and we just put the numbers in. So 784 divided by 98.00 times 5 divided by 3, and the answer I get here is 13.3. I think I may have made a mistake. Let me do this again. 784 divided by 98.00 times 5 divided by 3. Okay, now the answer I get here is 16.0 moles. Okay, so 16.0 moles. And that's how you do that. All right, so that's an example where you start off, you're given a balanced equation, and you start off, you're given a balanced equation, you start off with the mass in grams of one substance, they give you that, and you're asked to find the moles of another substance based on the balanced equation. All right, okay, so that's one example. Here's another one. In this case, they give you this equation. Again, it's balanced, and again, you're given a mass of one reactant, which is hydrogen, and you're asked to determine the number of moles of the product, which is ammonia. So actually they gave you the moles of ammonia. I'm sorry, they gave you the moles of ammonia, and you're asked to find the mass in grams of hydrogen. So it's kind of working backwards because they gave you the moles of a reactant. So they gave you, convert this to pen first. So they gave you 12.0 moles of ammonia, and you are to convert this to equivalent mass of H2. Alright, so the first thing I would do is start off with what we were given, 12.0 moles of ammonia, and then I will look at the equation to look at the relationship between ammonia and hydrogen, and you can see there's a 2 to 3 mole ratio between the two. So in the conversion factor, I'm going to write down here as the denominator, I'm going to put 2 moles of ammonia and 3 moles of H2. Alright, and then in the next conversion factor, I would convert the moles of H2 because this will cancel here and here. So I'll convert the moles of H2 to grams of H2. So this is where molar mass comes in. So I'm going to put 1 mole of H2 down here, and the molar mass of H2 would be 2.016 grams of H2, and let me do my number crunching, times 3 divided by 2 times 2.016, and the answer I got is 36.3 grams of H2, and that's how I would do that. All right. Okay, so those are 2 examples where you're given the grams of one substance to get the moles of another substance, or vice versa. In both cases, of course, as you can see, and I'll stress this again, you need to have a balanced equation. You need to make sure that your equation is balanced. Okay, so here we're going to get into some examples where we're doing mass-to-mass calculations. So basically, we'll be following the same steps as we did before, excepting that there's one additional step, and that is that you'd have to convert from either the mass of one substance to the moles, and then you proceed in terms of, if you're given the mass of one substance, and then you go through all the steps to get to the moles, and then you convert the final moles to mass. All right, so it's basically one step longer compared to what we have looked at before. So in this example, we're using the same reaction that we saw before, but this time you're given 112 grams of hydrogen, and you're asked to determine the equivalent mass in grams of NH3. So the way you go about this is that you start with the grams of hydrogen, convert to moles of hydrogen, moles of H2, then you convert from moles of H2 to moles of ammonia, and then from there you're going to convert to grams of ammonia. So as you can see here, you're going to need to employ 3 conversion factors in series in order to carry out this process. So we're going to start with 112 grams of H2. We're going to convert it to moles. So you're going to have 1 mole above and of H2, that is, divided by 2.016 grams of H2, that's a molar mass. The grams of H2 units will go, so that would be the first step. And then the next step is where you convert from moles of H2 to moles of ammonia. You're going to be using the coefficients to establish that conversion factor. And up top, as a numerator, you're going to have 2 moles of NH3. Down below, as a denominator, you're going to have 3 moles of ammonia. And then that takes care of canceling out these, 3 moles of H2, my bad. H2, this should be H2 here. So the moles of H2 will go there and there. And then the last step is where you go from moles of ammonia, 1 mole of ammonia, to the molar mass. And the molar mass of NH3 is 17.03 grams per mole. So you're going to have up top here 17.03 grams of NH3. So the moles of ammonia will cancel here and here, and you work this out. So let me do that on my calculator. So I'm going to have 112 divided by 2.016 times 2 divided by 3 times 17.03. And according to my calculation, this works out to be equal to 631 grams of ammonia. All right. So that's how we do that. All right. Okay. So next, okay, we're going to stop here for today, and we're going to look at the concept of limiting reactants and percent yield. All right. So until next time.